So notice that the problem has kilonewtons per coulomb as its unit, so we might want to convert that into Newton per coulomb by multiplying it by 1,000. And for the area, because we have a rectangular figure, we can just simply multiply the length by its width. So gathering all the given and multiplying that all out, we'll have an electric flux of 1822.5 Newton times meter square per coulomb. So for part B, we have the electric field still pointing along the x direction, but this time the rectangular plane is parallel to the xy plane. And so we're going to attempt to draw a rectangular area that is parallel to the xy plane. And of course, the xy plane is the standard coordinate axis that we're using, and if it's parallel to that plane, then that rectangle might look something like this. And remember that we have to draw the area vector for the rectangular plane. And once again, the area vector will always be perpendicular to this rectangular surface. And it may be hard to visualize this, but if we draw a line that's perpendicular, then that line would be projecting along the z-axis. And this would be a 90-degree angle because it's perpendicular with the rectangular plane. And then we have to ask ourselves, what is the angle between that area vector and the electric field? If it helps, you can slide this area vector a little bit over and situate it right on the z-axis. So that would be an equivalent way to represent that vector. You can do the same thing with the electric field vector. You can slide it up and put it right on top of the x-axis. And then hopefully, we can see that the angle between that area vector in blue and then this electric field vector in red is a 90-degree angle. And we know that because the angle between the z-axis and the x-axis is of course 90 degrees. And there's a little bit of shortcut here. Then because the cosine of 90 degree is 0, so when you plug in the 90 degrees for theta, you're going to end up getting an electric flux equals to 0 degree Newton times meter square per coulomb. So this would be the right answer to part B.